Okay, so we're going to take a look at these now. Chad, make sure you take your seat. Awesome. Quit turning around and staring at Chad. I know you love him, but you can talk to him later after class. But seriously, let's get down to business. I forgot. Drew, Brandon, quit holding hands. And Carrington, bruh. So, number one, if you are taking and you are multiplying two complex numbers together like we did last time in class. If you take negative 1 times 11, you're going to get negative 11. Negative 1 times negative I, you're going to get positive 1i. 2i times 11, you're going to get 22i. And 2i times negative I, you're going to get negative 2i squared. When you add these together, you are going to get I plus 22i is 23i. Treating it very much like a variable. But remember, I is not a variable. I squared, remember, is equal to negative 1. I told you this last time in class, you would always replace it with a negative 1. So this actually is plus 2 out here on the end. So you have negative 9 plus 23i when you add 2 and negative 11 together. Number 2, 8 plus 5i minus 1 plus 2i. Notice this is subtraction. So what you can do is you can change this to addition and make both of these negative. Or you can just go through and use subtraction as you go from 8 minus I to 5i minus 2i. As long as you use subtraction, you'll be okay. It's just collecting like terms. Don't overthink it. So 8 and negative 1, or 8 minus 1, is going to be 7. 5i minus 2i, or 5i plus the negative 2i, is going to be 3i. Just collecting like terms. Number 3. Most of you on this one probably just gave up, didn't even try it. Some of you that tried it probably looked at x plus 5 squared and thought that you needed to multiply x plus 5 times x plus 5 to get this thing into what we call standard form. It would give you x squared plus 10x plus 25 if you did the FOIL method on x plus 5 times x plus 5. Then if you distributed the 3, you'd get 3x squared and 30x and 75. Then you would subtract the 24. If you subtract the 24, you're going to get 75 minus 24 is going to be 51. You got it equal to 0, and then you would think to try to factor this and solve it. I'm glad you're thinking that if you are. If you're not, I can't believe you're not thinking that, because that's what we've been doing this entire chapter so far, the past at least 4 or 5 class periods. So when you look at this, you could take this and divide a 3 out. You get x squared plus 10x plus 17 equal to 0. The factors of 17 are 1 and 17. That's not going to give you 10. So that is where you have an issue. Sometimes in quadratic equations you cannot factor. So you have to be able to solve it a different way. One of those ways is if you can get the equation to look like what we started with. Notice that what we started with here, if I would have taken it at the very beginning and divided by 3 on both sides, it would have canceled out the 3 on the left and left me with x plus 5 squared. 24 divided by 3 is 8. And so then I have x plus 5 squared. That's a perfect square. We know how to solve that by using the square root on both sides. That's what we talked about a lot last class and even the class before we took our little mini test. So you take the perfect square and take the square root of it. And you get x plus 5 is equal to plus or minus the square root of 8, which most of you probably are yelling at the computer screen right now. It should be 2 on the square root of 2. That's what we spent a lot of time doing last time in class, right? So then you subtract 5 over. Now I'm going to show you something here that I do that is not required, but it is the way I always write these. I always take, when I subtract 5 over, I put negative 5 plus or minus 2 on the square root of 2. It looks better this way with the number in front of the plus or minus. It's also going to tie with something that we look at next class when I return on Friday. But it's also going to help you guys out when it comes to the calculator. If you went to type this into the calculator and you forgot a parentheses and you had your minus 5 over on this side instead of in front, it would mess up if you forgot a parenthesis. And so I'm trying to help you guys out by putting that -5 in front of the plus or minus. There's still two answers, -5 plus 2 on the square root of 2 and -5 minus 2 on the square root of 2. But you can leave it as this answer if you don't want a decimal answer or don't need a decimal answer. So what our goal is today is going to be able to get something that doesn't factor like we had over here on the left and make it look like the one that you see up here at the top. We're going to make it be a perfect square. This process is called completing the square. So this process of completing the square is going to be to make an equation be a perfect square on one side. So take a look at this guy. See if you can take the left-hand side of this equation and rewrite it to look like the left-hand side of this equation into a perfect square. Maybe without the 3 out front. See if you can rewrite it. Take a second to do that. Pause the video. So, you should have gotten this as x plus 5 squared. Why? Because x squared plus 10x plus 25 is the same thing as x plus 5 times x plus 5. Notice that I have set this one up perfectly for you. In just a little bit, we're going to figure out how to make this happen even if it's not perfectly set up. So we take the square root of both sides if I want to solve this. X plus 5 equals plus or minus square root of 36 is 6. Subtract the 5 over and you get -5 plus or minus 6. What's -5 plus 6? That's 1. -5 minus 6? That's -11. There are my two answers. On this one, these are pretty nice answers compared to the last one because that was a perfect square of 36 on the other side. That won't always happen. But when it does, that means you could have subtracted 36 over, set this equal to 0, and factored it and still got the same two answers. So, factoring is still there. Factoring is still something that we want to use when it's easy. But sometimes we were going to want this process so we can solve it by a different way. We're going to get to that here in just a little bit. Alright, so try this one, same way. Pause the video. So, on the left-hand side of this equation, you should be able to break this down into x minus 7 squared because this splits up into x minus 7 and x minus 7 because that gives me the -14 and the +49. Still based on our factoring principles, but that's one of those special patterns. That is a perfect square trinomial like we talked about. So then I can take the square root of both sides, get x minus 7 equal to plus or minus the square root of 81 is 9. So then I add my 7 over. That's going to be +7 plus or minus 9. What's 7 plus 9? Well, it's 16. What's 7 minus 9? -2. So there's my two answers. So what happens when we don't have it perfectly set up from Mr. Harrison is what we're going to talk about next. We're going to talk about a process that is called completing the square. The process of completing the square means you are going to make that parenthesis squared, or that binomial squared is what this says right here, a square of a binomial, out of something that has 1x squared and a bx, a number times x. What I mean by that is this. If I have x squared plus 2x, I can add something to this to make it be a perfect square. In other words, I'm going to make it happen. Guys, notice the word completing. It is a verb. That means it is something that you are doing to make it happen. You are completing the square. So that means you are making this be a perfect square. So if I want to make this be a perfect square, what I do is I use a little formula that's right here. Now this formula is not one that you need to spend too much time memorizing like you did the -b over 2a, because it can kind of get you confused with that one. But basically what I do is I take whatever number is right here, the b value, and I divide it by 2, and then I square it. and that will make this a perfect square. So, if I take 2 right here, divided by 2, I get 1. When I square 1, I get 1. So right here, this would make this be a perfect square. So what does it break down into in parentheses right here? Well, using our skills that we did back here and back here, we can break this down into x plus 1 squared. Why is it 1 right here, Mr. Harrison? Because what was 2 divided by 2? It was 1, and that's what we did to get this squared right here. That's what's going to be here. Notice that right here in this little pattern, b over 2 is what gives you the number inside the parentheses. So not only does taking this b divided by 2 give you the number that you're going to get right here to make it a perfect square, but it also gives you the number that's in the parentheses. So basically what you're doing is you're trying to figure out what number goes here to make something be a perfect square. Even though on these two, Mr. Harrison gave them to you, now you're going to have the skills to be able to do it yourself, to figure out what number needs to be here. Okay? So, if you need to pause the video here so you can copy down some stuff, that's fine. Then we're going to take a look at now you trying it on your own. In other words, what I want you to do is I want you to take x squared minus 8x, and I want you to find the c value that makes this be a perfect square trinomial, which can be rewritten into a binomial squared. So try it out. Pause the video. Now, negative 8 divided by 2 is negative 4. When you square negative 4, you're going to get the answer that you need to have right here to make it be a perfect square. So, what is negative 4 squared? So let me write this out for you so you can see exactly all the steps that I'm taking before I skip a couple steps here. So negative 8 divided by 2 is negative 4, and then you're going to square it. So negative 4 squared is going to be positive 16. Notice that that last number is always going to be positive because you're squaring whatever you did when you divided this by 2. Now, what does that break down into? That breaks down into x minus 4 squared. Where did I get the minus 4 from? Remember, when I divided negative 8 by 2 and squared it, that number, negative 4, is what's going to be down here as well. All right, here's another one for you to try. Notice that this one, it might be a little ugly. It's okay. Try it out. Pause the video. So right here, you take x squared plus 7x, you divide the 7 by 2, and you square it. Yes, that one is not perfectly divisible by 2. So what you should get here is 49 over 4. Or yes, I know some of you are going to say 12.25. You're right, it is 12.25, but I'm going to leave this as a fraction. Remember, I need to be able to work with the fractions sometimes because sometimes I don't have such a pretty little number here like 12.25. What's going to be in parentheses is x plus 7 over 2 squared. I got 3.5. I know you did. That's what 7 over 2 is. 7 over 2 is 3.5. So when you split this up, just like we did before on the last page, the negative 8 divided by the 2 gave me the negative 4. That also ends up being down here. Same thing happens here. The 7 divided by 2 also ends up being here. Now I know some of you are thinking, well, why can't I just skip all the way down to here, Mr. Harrison, without doing that? Because this is going to become important when we start solving equations here in just a little bit. In fact, right now. So, when we look at x squared plus 10x minus 3, don't try to wrap down this entire paragraph, please. This is just something that's telling you what I'm about to say. In the first part of the chapter, back in section 5.2, we learned how to solve this by factoring. So what we tried to do is we tried to split this up into the factors. We said x and x gives me x squared. It's a negative 3, so I'm going to have plus and minus. The factors of 3 are going to be 1 and 3, but neither one of those is going to work to give me 10 in the middle. And so that becomes the issue. Sometimes you can't solve something by factoring. And so what this process that we just learned called completing the square is a method to get one side of the equation to be this perfect square, to be this perfect square, to be this perfect square, to be this perfect square. Have I made my point yet? I hope so. What we're trying to do is we're trying to get it so we can solve it exactly like we did this guy right here. So, let's go back and take a look at that x squared plus 10x minus 3. If you will watch, I'm going to lay out the process that you can use anytime you need to complete the square. So, what you're going to do first is I always add the 3 over to the other side. Because once I figure out, oh crap, this doesn't factor, I add the 3 over to the other side. Then what I'm going to do is I'm going to make the left-hand side be one of those perfect squares. This is what we just did just a minute ago, guys. If you cover up this side right here, you will see this is the exact same thing that Mr. Harrison just talked about just a few minutes ago. Take the 10, divide it by 2, and square it. Now I'm going to stop writing out this whole process, so you need to be able to see what 10 divided by 2 squared is. Take out your calculator. I'm just going to do it all at once. 10 divided by 2 is 5. 5 squared is going to be 25. So you want to add 25 over here. The problem is, what you just did is you added 25 to the left-hand side of the equation. So guess what you got to do? You got to add 25 to the right-hand side of the equation. So what that does is that gives me on the right-hand side is 28. On the left-hand side, this is a perfect square. This is why we call this process completing the square. Because what you are doing is you are making this side be a perfect square. So you know when you do this, it's going to be x plus 5 squared. Where did I get the plus 5? Remember, the 10 divided by 2 gave me the 5. Just like I looked at here on this problem back here, just like I looked at here on this problem right here. I am taking it and I am breaking it down into a perfect square. So now what I can do is I can solve this by taking the square root on both sides. That gives me x plus 5 equals plus or minus the square root of 28. Now, I'm going to go kind of quick through some of these when I'm dealing with the square root. You might need to pause the video every once in a while and rewind it to hear me say what's happening. 28 is 4 times 7. So I'm going to take the square root of 4 and get 2 and leave the 7 on the inside. Remember, 4 times 7, take the square root of 4, leave the 7. So, on the left-hand side, I still have a plus 5, so I'm going to subtract 5, and that's going to give me negative 5 plus or minus 2 on the square root of 7. If you need a decimal for this, you take out your calculator, and you do negative 5 plus 2 on the square root of 7. Press enter, and you do negative 5 minus 2 on the square root of 7. Notice that there is a plus or minus. So you do both of them. And you will see that your answers are 0.29 and negative 10.29 if you were finding the approximation in decimal form. So there are 2 answers, just like we did when we were factoring. The difference is these are ugly. This is why these don't factor. So you've got to have another way to solve it. So I'm going to let you try basically the same steps on the next problem by yourself. Notice what I did. I moved the 3 over. I took the 10 divided by 2 and I squared it to get 25. I put plus 25 on both sides. On the right, 25 plus 3 is 28. On the left, that is x plus 5 squared. That is why we called it completing the square. You're making this happen, guys. This is not magic. You are forcing this to happen. Then you subtract the 5 over, put it in front of the square root. You can leave your answer as this one over here, or you can get your decimal answers. I would probably prefer you knowing how to simplify radicals, because when you get to imaginary answers, you're not going to have the choice of doing decimals. Try this one. Pause the video. Okay, so you should have tried this guy. Just like the last one, I'm going to move the 5 over. So I'm going to subtract 5 over to the other side. Then I'm going to make the left-hand side be a perfect square. This is why we call it completing the square. Yes, guys, I'm going to repeat that until you feel nauseous from me saying it. So you're going to be making this a perfect square. So what is negative 12 divided by 2? That's negative 6. When you square it, 36 is what I need to add to both sides. Why did I add 36 on the left? Because now I have a perfect square. On the right, negative 5 plus 36 is 31. So on the left, it is x minus 6. Where did I get the minus 6? Because what was negative 12 divided by 2, guys? It was negative 6. So now you can take the square root to solve on both sides. Notice that on the left-hand side of this one, it gives you x minus 6. On the right-hand side, don't forget your plus or minus. The square root of 31 over here, when you take the square root of 31, you can't split it up. So that is all you can do, is still just leave it as the square root of 31. Add the 6 over so you can get positive 6 plus or minus the square root of 31. All right, try this guy. Pause the video. Okay, so on this guy, x squared plus 4x minus 4, I'm going to add the 4 over to the other side. Now, I know some of you are saying, wait a minute, Mr. Harrison, that is a perfect square. You're right, it is. 4 is a perfect square, but it's minus 4. That is not what we talked about on the last couple of pages. What we talked about on the last couple of pages is adding something, which is going to be positive to both sides to make this left-hand side be a perfect square. So, again, you're making this happen, completing the square. So you're making it be a perfect square here. So what's 4 divided by 2? That's 2. 2 squared is 4 is what I should add. But you said 4 doesn't work. No, I didn't say 4 doesn't work. I said negative 4 doesn't work. That's why I'm adding this positive 4. So on the left-hand side, you have x plus 2 squared. On the right-hand side, you've got 4 plus 4 is 8. Where did I get the plus 2 from again, guys? It's from the 4x divided by the 2 there. So that's where you get that 2 from. That's where we got this 6 from. That's where we got this 5 from. It doesn't change, guys. The process is the same the whole time. You can notice as I switch pages that I'm doing the same thing every single time. When I take the square root now on both sides, I get x plus 2 equals plus or minus. The square root of 8 is 2 on the square root of 2. Yes, we've done that one about 500 times. You should know it by now. Then I subtract the 2 over, so that's going to be negative 2 plus or minus 2 on the square root of 2. All right. So, now I want you to try this guy right here. Pause the video. Alright, so this one's got a little tricky part to it. Some of you probably panicked when you got there. It's okay. I'm going to show you what to do. You subtract 36 over, that's going to give me negative 36. Then I'm going to do the exact same thing we did on the other problems. I'm going to take this guy and I'm going to add something to both sides to make it be a perfect square. This is called completing the square. Didn't I tell you I was going to repeat that over and over again? Oh yeah, I did. Negative 8 divided by 2 is negative 4. When you square it, that's 16. So you're going to add 16 to both sides. On the left-hand side, this becomes x minus 4 squared. On the right-hand side, negative 36 plus 16 is negative 20. Uh-oh. Yes, that's going to cause a problem because now when I take my square root on both sides, I'm going to get x minus 4 equals plus or minus the square root of negative 20. How in the world do I do that, Mr. Harrison? I don't know what to do. I know, you're panicking, but remember, this is what we talked about last time in class. I'm going to come over here to this side and talk about it. Negative 20 can be split up into negative 1 times 4 times 5. Why did I do that? Because I can take the square root of negative 1. We talked about that last time in class. That's in the imaginary unit. Square root of 4 is 2. And the square root of 5 I can't do, so I'll leave it on the inside. So what you're going to have is plus or minus. You take out the I for the square root of negative, and you take out the 2 for the square root of 4. So you have 2i, and you leave the 5. Guys, if the negative wasn't there, it'd be 2 on the square root of 5. So the only difference that the negative causes is an I has to come out. Remember, we joked about it last time in class. Take out your I. I mean, not yours, but on the paper, right? So, Then you add the 4 over to the other side. That gives me 4 plus or minus 2i on the square root of 5. This is why I said you can't just always rely on the calculator to do these, because this one you could not type into the calculator to get a decimal answer. Alright, so let's take a look at what would happen if you saw something like this guy right here. Okay, so I want you to take a look. See if you can figure out how to start this thing. Take a couple seconds. Okay, you're stumped, right? Well, the reason is because the 3 is in the way. Now, most of you are going to try to start doing stuff that we did on the other problems, but you're going to not notice the fact that Mr. Harrison pointed out back here, when we talked about what completing the square is that it has to be 1x squared. So, that's not 1x squared, is it? That's 3x squared. So what do you do when there's a number in front of that? Well, it's actually a lot simpler than it looks. Just like on the other problems, I always move my 12 over. When I realize something doesn't factor, I move that 12 over so I can start this process of completing the square. Then I divide everything by 3, and it gives me x squared minus 2x equals negative 4. Look at there. Now we're exactly like those other problems that we just did just a little while ago. One thing I do want to point out here, guys, is that sometimes when you divide by something, like if you divide by this 3, if 6 was not divisible by 3, it might give you something ugly here, but it doesn't change the process. You're still going to take whatever you get right there beside the x and divide it by 2 and square it. Doesn't matter what it is. Since it's negative 2, I'm going to divide negative 2 by 2 and square it, and that's going to give me positive 1. Positive 1 is what I'm going to add to both sides. If this was 10 million right here, I would divide it by 2 and square it. If it was 13 over 6, I would divide it by 2 and square it. It doesn't matter what this is, divide it by 2 and square it. That is called completing the square. You're making it happen. You're making it work. So on the left, this is x minus 1 squared. On the right, negative 4 plus 1 is negative 3. Then you take the square root on both sides. That gives me x minus 1 equals plus or minus I on the square root of 3. Yes, the I comes out, but the 3 stays on the inside. And that's the only thing you can do with this one, is take the I out, like I told you to do with any negative inside a square root. Then you add the 1 over. That's going to give me 1 plus or minus I on the square root of 3. Wow, what just happened, Mr. Harrison? It just flicked over to a word problem? Yes. Word problems are great uses of these new ways of solving, because sometimes word problems end up being ugly numbers and not always nice little things that you can factor. So in this problem it says, on dry asphalt, the distance in feet needed for a car to stop is given by d equals 0.05 s squared plus 1.1 s, where s is the car's speed in miles per hour. What speed limit should be posted on a road where drivers round a corner and have 80 feet to come to a stop? So what is this 80 feet? It's the distance that you have to stop. So you plug in 80 for the distance, and then you solve this equation for s. Yes, I know I've got a 5 and an s right there beside each other. I'm sorry. You're going to have to deal with it. I'm going to remind you what it is, so make sure you listen to me. I'll tell you what's a variable and what's a number, okay? So, just like the one that we just looked at, this is 0.05 in front of the s squared. So if I want to solve this, the first thing I need to do is divide everything by 0.05. So the same thing applies just like we did on the last problem when I divided everything by 3. So you get s squared here. When you take 80 and you divide it by 0.05, take out your handy dandy calculator if you can't do it in your head. Okay, I'm going to do this so I make sure I get it right myself. You divide 0.05 and you get 1600 over here. Then you divide the 1.1 by 0.05. Again, take out your calculator. Make sure that you can get the correct answer for this. When you divide 1.1 by 0.05, you get 22. So this is 22s. So notice now I am on this equation just like I did way back here when I was looking at this one after I divided it by 3. Then I'm just doing the completing the square process, exactly like we've been practicing on for several problems we've done today. So you take this and you say, okay, I'm going to make this be a perfect square. So I'm going to add something to this side, and I'm going to add the same thing to the other side to make it work. So you take 22, you divide it by 2, and you square it. When you take 22 and you divide it by 2 and you square it, 22 divided by 2 is 11. 11 squared is 121 is what I'm going to add to both sides. That gives me 1721 on the left. On the right, it's a perfect square. Guys, you are doing the same thing we did a minute ago. You're making it a perfect square. So guess what? This is going to be s plus 11 over here. So you end up giving yourself something you can take the square root of. You get s plus 11. That's a variable s right there. Square root over here. So when we took that square root, we have to put that plus or minus. Then we subtract the 11. So it's going to be negative 11 plus or minus the square root of 1721 to get my speed. Guys, you're talking about the speed of a car. So make sure you realize on this one that you need just the positive answer. So when you do negative 11 plus the square root of 1721, Mr. Harrison, why are you not going through and simplifying that radical? Well, because I'm looking for speed, guys. I want this to be a decimal, not going through and finding a radical. So when I find my decimal answer for this one, it gives me 30.48. Notice that if I did negative 11 minus the square root in my calculator, just like I did negative 11 plus the square root, it's going to give me a negative because that's negative 11 minus something. I don't want that. So my speed, or my approximation for my speed, is about 30.48 miles per hour is what this is measured in. But think about up here what the question said. It said, what speed limit should be posted? Guys, you don't want to post anything above 30.48. So what they would probably post as the speed limit here is 30 miles per hour posted speed limit. Because that is what you would actually want to drive to keep yourself from running through that stop sign after you come around the corner. There are state troopers who actually use equations like this to figure out wrecks. Now, they do have some computers and things to help them out, so I'm not going to say they're going to pull out their pencil and paper on the side of the road, but they use these types of equations to figure out how fast somebody was going when they stopped in a wreck. Because you can measure the distance of the tire marks and see exactly how fast they were going, so they can find out if you were at fault or if speed was a factor. If you were going too fast for the conditions for the road. In this case, when you come around this corner, you only have 80 feet to stop, so you need to be going 30 miles per hour or below. All right, the last type of question that you're going to see that involves using the completing the square process is something called rewriting in vertex form. Remember, this is standard form, ax squared plus bx plus c. But vertex form is a times x minus h squared plus k. Guys, notice something here is the parentheses squared. That's what we've been doing all class to get solutions. Now we can use this to also help us take this and rewrite it into this form. So what we're going to do is we're going to take it step by step. Watch what happens here. I'm going to take the first step exactly like I did on the other equations. I'm going to take this 11 and I'm going to subtract 11 beside the y. The difference is y is a variable, so you can't really subtract 11 from it. You just put it beside it and that's it. Then I'm going to take the right-hand side of the equation and I'm going to add something to it to make it a perfect square. Why do you want to do that, Mr. Harrison? Because I want it to look like this. I want it to have this perfect square right here. So I take negative 8 divided by 2 and square it. Negative 8 divided by 2 is negative 4. Square it is positive 16. And so I add 16 to both sides. On the left-hand side, that gives me y minus 11 and plus 16. That ends up being positive 5. Those are like terms. On the right-hand side of the equation, this was the whole reason for me doing this, is it's a perfect square now. Why did I get minus 4 in? Because negative 8 divided by 2 was what gave me negative 4 to get the 16. So then all I have to do to rewrite this in vertex form. Now everybody's like, wait a minute, administration, do you take the square root now? Do you take the square root? No, don't take the square root. You're not solving for x in this one. You're trying to get it to look like this form. So you take and you subtract the 5 over to get y by itself, and what you end up with is this x minus 4 squared minus 5. Notice there's my vertex form. Right here, if you take the opposite of this and the same as this, like we did back in the earlier part of the chapter, there's your vertex staring you in the face. Now you don't have to do this every time. You don't have to find your vertex every time. But I was showing you that it's the same stuff that we talked about earlier. The key is that you can rewrite it into this perfect square like we did on the other ones and get this into vertex form. Alright, so I got one for you to try here. Try the one on the left. The one on the right is the same one that we did just a minute ago. So try the one on the left. Pause the video. Alright, so here we go. So y minus 2, I subtract the 2 over to get it over to the other side. Then I'm going to add something to both sides to make the right-hand side be a perfect square trinomial. Making it a perfect square. Remember, completing the square. So what do I add? I take 6 divided by 2, that's 3. 3 squared is 9. So 9 is what I add to both sides. It gives me y plus 7 on the left. On the right, that ends up being x plus 3 squared. Remember, 6 divided by 2, was what gave me the 3 here. Also gave me the 9 that I had to add to get the 7 over here. Do not take the square root here. All you need to do now is subtract the 7 over. So when you subtract the 7 over, you're going to get minus 7. There is my vertex form. So I went from standard form into vertex form. This is not a huge useful process, but it is something that you can use if you want to get it into that easy form. You can do it. Personally, I just like to use the standard form if I'm trying to find the vertex. There's no reason for me to do all this just to find the vertex. I can do the opposite of b over 2 times a and get my vertex x value and plug it in to find my y. Alright, one more on the left. We'll be done. Pause the video. Alright, so you add the 2 over. You get x squared minus 10x. And so then, once you've added the 2 over, you're going to try to make the the right-hand side be a perfect square. So I take 10 divided by 2 and square it. 10 divided by 2 is 5. 5 squared is 25. 25 is what I add to both sides. So that gives me 27 on the left. On the right, it's x minus 5 squared. Remember, that's where we get the 5 from, is from the negative 10 divided by 2. To make it a perfect square, it's going to be there too. Then you subtract the 27 over, so you get x minus 5 squared minus 27. Alright, so here's your homework, page 54 in your book. Make sure you get that written down so you can get your problems that you practice for this completing the square. We're going to take a look at it some more next time at the beginning of the class. I'll review it with you. I'll also review any questions you may have had off of page 45 that you turned in at the beginning of the class today. So we'll take a look at that too if you have any questions. I'll see you guys on Friday. Make sure if you have any questions or anything, if you need to finish your mini test, that you come back in and finish that.